Hi, we're back to talk about the MrBulletFeeder and the control system that we made for it to work with small caliber bullets, and 22 caliber bullets in particular. The first unit that we made was successful. It worked. I've made quite a few of them, and they work. They work just fine. Here's the basis of it. This is the 3D printed part, and it sits on top of the, where is it? The MrBulletFeeder. This is the MrBulletFeeder die, and this sits up on top of it. Well, that one hasn't been sized out yet, but at any rate, it sits up there, and the MrBulletFeeder feeder plugs in up here on top of that. The bullets feed through there. Now, the way it works is via this little piece right here. This is an induction or an inductive proximity sensor. If anything metal gets close to it, it trips internally and sends signals and changes and all like that. Well, bullets have enough of the appropriate metal that they, when they go past it, will also trip it. And the way this thing works is we have this little opening here where we screw in the sensor. And then, as the bullets feed into it, let me make sure you can see this, as the bullets feed into this thing, you'll see that, and they stack up, eventually there'll be one right there which will be sensed by the proximity sensor. And when it does that, it will send a signal, where did I put it, to a relay. Now, this is just a standard Bosch type automotive relay. Get them at any parts store, you can get them from Amazon, you get them anywhere. And we send a signal which energizes a relay and trips a switch in there, and that in turn is connected to the MrBulletFeeder and turns it on and off. So it's running. When the bullet gets to the top, it trips this, it closes that or opens that, and then MrBulletFeeder stops. And we have just use a little 12 volt or thereabouts wall wart to operate it. Now, this is wired in hard with all of this, and it's a bit of a gnarly mess, to be honest about it. There's just a lot of stuff there. And a lot of people have asked me about buying these, and I've been a little hesitant because the parts are scattered all over. You got to figure out somewhere to mount the relay, wire in the power supply, all these wires have to be connected, and there's 14 million ways you could do it wrong and one way you can do it right. So the odds are kind of stacked against you. What I really wanted was something super simple that I could make for people who really want one of these things. And that's what I've come up with here. And I was looking for something. Oh, well, this is the complete unit. This one does not use a proximity sensor, it uses an optical sensor. We'll get into all that when I show you the guts and gizzards inside of this thing and how it works. But the big object was to make it as simple as possible for you, whoever has one of these, makes one or buys one, whatever the case may be, to make it to hook up. Well, one of the problems, I'm sorry about this rat's nest, but as I've said, if you want to see a video, you're just going to have to put up with this because I just don't have time to clean it. Here's your power, and we put a power plug on the bottom. So you just, any wall wart plugs in there, that's it. That's one of the connections. The other one is the MrBulletFeeder. It has two spade connectors on it, and they match up to these two spade connectors up on top of the new sensor, and you just plug those on. And it does not matter which one goes where. They're two. Just plug them together, and that's it. You're done. So how does this marvel of technology from Rex Roach Designs. How in the world does this thing work? Well, it works very well, I'll tell you that. So let's get into it real quick. Before we do, I do want to say something about MrBulletFeeder. If you can do what I've done here, I would highly recommend it. And that is, I just clamped a piece of angle iron here on the edge of the bench and mounted the MrBulletFeeder. That gave me a chance to easily get at everything and get everything adjusted. Let's look around here on the back. On the back, you have all the various parts used. They look like Tinker Toys blocks to put everything together. And there's an awful lot of adjustment that can be made. I'm not going to get into it, but I am here to tell you, if you will set this thing up like I've done here on a piece of angle iron, and then you can get to it, and you can do a good job on them. I'm trying to get there so you can see the various parts. But there's all kinds of stuff here to make adjustments. And one other tip is get yourself, let's see, it's a 5/30 seconds, right? Is that it? Yeah, 5/30 seconds. You get one of these, and that will make your life a lot better, because you can get in there and crank away and get everything. But, you know, regular wrench will work fine. But the important thing is you do that. Now let's look at it from the front here. It's very important that MrBulletFeeder be oriented correctly. This needs to be at least 45 degrees. I recommend it be between 45 and 50. Don't go less than 45, and that will keep the bullets that way. And it also helps them to fall when they're not in the correct spot, because a lot of what goes on is just where if they're not right and they're riding up on the corner or something, when they get to a certain point, they'll fall. And you need gravity. Gravity is your friend, and you need that to be at 45 degrees. Now, while that's at 45, this right here, you want to put a level on it, and it should be level or almost so. If anything, this side, this outside, needs to be a little higher than the inside. Again, that's to allow things to fall away from here as they're coming up. But you don't want it tilted that way. You know, the easiest thing is just put a level on there and shim it until it's level. And that one's right on the money level. You can see right here, I put a thin wooden shim in and cause it to turn outward. It makes this Tinker Toy part tilt that way, and that's in an effort to level it. But I had to shim it because this thing is made to fit a variety of sizes. You may not need to shim it so much on the hopper, but play with it down here until you really get familiar with it. And furthermore, this will give you a chance to really see how it works and fine-tune the operation of it if you do it down here rather than up on the machine. All right, let's do some testing now. Just MrBulletFeeder, nothing else in there. And all I'm looking for is to make sure it'll feed, so I've just got the empty spring hanging down there. All right, so here we have it, and we've got our little short, these are the little problem bullets. They're so tiny, they're so short. There is a problem in that sometimes you'll have two like that come along, and most of the time gravity will take care of them, but sometimes they'll fall in behind this little snapper. And that's okay as long as that's all that's there, because eventually a blank will come along and this one will fall into the blank. But if you get too many in there, they'll start falling out and kind of going everywhere. All right, watch this blank. There it went right there. So, you know, it has possibility of jamming, but this is why it's so important that you have everything oriented at the correct angles. All right, now we are ready to do a complete full 100% test. We've got the little feed spring connected to the top of our device. We've got the 2 wires from MrBulletFeeder connected, just the push-on tabs, and we've got our power plugged in underneath, and that's just like that. And even without looking, you can get it right in there. All right, and so this will fill up because it releases when the cartridge comes up there. Let's move in close. Well, let's start, and you can kind of see the overall, then we'll move in close. Right, so we're feeding bullets, and they're filling up in there. Now they're up to here. We can see them, and in just a moment it'll stop. Ta-da, like that. And then if we take a case and simulate what would happen when on the press, you could hear it turn on. And it doesn't do it every time because it has to drop. There it goes. So sometimes it'll be 2 bullets before it does it. Let's move in close. It's a pretty crude arrangement, but hey, it works. It's effective. So let's tell you what we'll do. We'll dump a whole bunch of bullets. Now we'll let it fill back up. Now you can see them coming in there. And when it gets to the top, off it goes. And if we take our case and take out 1 bullet, it didn't come on because it didn't drop. I don't know. There it goes. But it will never let you run out of bullets. For those of you who have been following this for a while, the original switch for the MrBulletFeeder was in a device pretty much like this, and in it we had screwed a sensor, an induction sensor, and this sensor right here senses the presence of metal. And I've decided to go an entirely different route, and here's the heart of the thing. It's this little circuit board which will fit down inside like this, and this will be the entire unit. There won't be anything else, or in other words, we won't have an external relay, or we won't have that sensor sticking out and all that. Here's how this works. This has a photocell, IUS, what we used to call electric eyes, what we used to call them. And it's actually a photoresistor. It changes resistance with the amount of light that's shining on it. And if you shine a light on it, it will be at some value, and if an object breaks that light, such as a bullet stacking up and getting in the way, then it will change a lot, which will change the circuit. That will cause this relay to trip. And this is what MrBulletFeeder is connected to. This relay will replace the external one that we had before. Works just fine. Normally it will be like a switch that's closed, but when the light gets broken, the switch will open. So as long as the tube is empty, MrBulletFeeder is turned on, but once the tube fills up, MrBulletFeeder will stop because this will open up. And like I said, it all goes down in here. Now, if you will look kindly, please, you will see that the photocell is right down there. And when I take it out, you will see that it was in front of a little square window right there in the middle. And on the other side, you can see the other side. And there's also a window over here. But what we have is a pocket where we'll put an LED. And that LED will shine through all the time. And when something goes down inside there to, block it off, screwdriver won't do it, but you get the idea, then that does the trick. And we got another hole over here at in that upper left area that goes through to this side. Yeah, you can see it down in there. And that's where the wires, the power for the LED will come from. It stays on all the time. And golly Moses, that's pretty much it. We got the cover plates. Oh no, that's not everything innovative about this one. There is something else new. There are two things that are new. Here's the cover plate, and on the original design, using the optical, I had the connections coming out for the MrBulletFeeder to plug in here. Well, it's not so good because you've got this springy wire that comes around and then coils back up, and it's kind of, it's creating problems. And you've got the power cord that's permanently soldered in place to the coming off one of these wall warts, soldered to the circuit board. Now, I wasn't crazy about that. Works perfectly. It is pretty compact, but I felt like we could do better. And so the idea here is we've added a bottom plate, and it goes in there like so. Ultimately, these will be glued together to be one, but the bottom plate has a opening for a jack, which will be for a power plug. So our wall wart plug will just plug in there, and that's it. You're done. Now, as for the hookup to MrBulletFeeder, where we were using these sticking out the bottom, that will be replaced by a barrier strip that goes on top into that opening and will be soldered to from inside, and the connections will be here. And look, we've got the little lugs that the MrBulletFeeder wires will just simply plug right onto, the exact same size as the MrBulletFeeder switch. And there'll be two of these, obviously. And it does not matter which one goes to which. So this is pretty much a no-brainer. You put the thing down, tighten this screw, put the top clap on and tighten its screw, plug in the power, plug in MrBulletFeeder, and you're done. You're ready to go. Plug MrBulletFeeder in up there. So I've had a lot of people ask me for these, and I've not really wanted to let them out because there was a good bit of fiddling and having to figure out where do you put everything, and it wasn't super simple. And this is. So I suppose I could be persuaded to part with some of these for somebody that really needed them, and you know what to do. There are comment places down below where you could make your wishes known. Not saying that we're doing anything to violate any kind of rules here. No. So anyhow, there it is. What I'm working on here is the latest iteration of the MrBulletFeeder adapter for the 22 caliber bullets. This one is fresh out of the 3D printer. I have stripped the support material out of it, and I've also used this cleaning brush right here to ream the bore, and that gets rid of any little burrs and, you know, things like that. And that, in turn, assures that the bullet will fall through there smoothly. That's step one. Let's see. Step two is there's a hole right here where a set screw goes to clamp it onto this is the place where it sits, and it clamps it onto that. And I drill it with a I mean, I don't know what the exact bit is, but I use a 4mm bit's perfect. And then I use a 1032 tap in here and clean it out with that and put the threads in there. And then after that, I can, oops. Well, you can use this little 1032 set screw and put that little guy in there like that, and there we go. And all right, it'll be slightly below flush when it's tight. All right, so let's do a little check to make sure this fits and this fits. This is an easy test. You just see if it'll go on there. It will. And then you look to see if the spring attachment from the MrBulletFeeder will fit, and it does. And that groove lines up with the set screw. Now we want to prepare these various mounting holes to receive the cover plates, and they're going to be screwed down with little machine screws that fit very nicely, and they will screw into these little brass nuts that will be sunk into it with heat. Here's one that I did before, and you can see how they wind up being. These are 3mm screws, and the holes are almost the right size, but not quite. And so I finish them out with a 4mm drill like that. So I had already done that while we were waiting for you to show up. And then at this point, we'll place them on there and set them with a soldering iron. What I have here is a Dremel drill press that I've modified with this little blue adapter, which I 3D printed, to hold a soldering iron and gives us more precise control. So now I'm going to give you a wide view of the whole process, and we'll attempt to get this one in there. There it goes, down in there. You get most of the way, and then you finish it by pressing against a steel plate. And if you do that, you'll get really good results. Where's the thing over here? Yeah. These little nuts have a reduced diameter on one end, which, get my hand in the way, I'll show you, get it out of the way, I'll show you, it fits right down into the hole. And so that kind of frees up one of your hands. And then we just come down against it, and what we want to do, we don't want to push it all the way. We'll push it about that much, and then immediately flip it around onto the steel plate, and there's the result. If you push it all the way, you'll wind up with a plastic ring. Here's one I can show you. You'll wind up with a plastic ring around the nut, and yeah, this one's that way also. It doesn't matter really. It's just unattractive, and it can create a slight offset right there, which would make your parts not fit so well. I'm going to hold this little blue plate right there so the camera will stay focused on the tip. And if you notice, it's stepped and it's straight, and that's unlike a regular soldering iron tip, which frequently has blobs of solder on it like this one, but they're typically sharp. And what will happen is the little fitting will ride up on it, maybe near the top, and because of the wedge shape, it will get wedged. And so when you pull out the soldering iron, the little nut will come out with it. This round tip with a flat face above it prevents that. Let's see if we can get a real close-up of one going in. I don't think I can get much closer than that, so yeah, here we go. And then I'll take it out and press it down over here against the steel plate, and there you can see how it works. So you may rightly be thinking to yourself right now, well, I don't have one of those special soldering irons. I've got a soldering gun. Is there any way I can do it with this? And yes, it is. Just don't try to push it all the way down. Put the heat on it, get it started, and then finish it off on the plate. And you see I got a little bit of solder on it, and that's so typical if you use a gun or an iron that you're also doing soldering with. I don't think there's enough there to matter. That one little whisker sticking out is going to have to go. It'll interfere. But so yeah, you can do it. But the steel plate is your friend. This is the key to getting them in there. If you try to push one in with anything all the way, well, it won't work. You may also be rightly wondering why I have to drill holes that are already there. Why do I have to drill these holes? Well, that one I'm not going to have to. Oh, good. These are. That one's clean. And that one's clean. That's good. Well, typically, when you 3D print holes, they tend to get smaller than actual, and something that's outside diameter tends to get bigger. But you can allow for that. So where I wanted a 4mm hole, I actually specified like a 4.2 or something. So apparently it worked nicely on this side, not so much on this side, but so be it. That's all right. We're cool. But you can ream them out, so to speak, with a drill. There are 4 of these mounting points down inside, and that's where the circuit board will be mounted. And these are tricky. You buy these things in bulk from various sources. Amazon is a real good source. You don't want to buy these kits like this where you get 300 pieces for $2 and whatever. And it's nice to have an assortment for occasional use, but I don't like this style. Let's see if I can show you what I'm talking about here. I don't like this style. If you look, you'll see that the ones I'm using have the little pilot section to guide it in, whereas these others have knurls on both ends. So they just have to sit up there, and you have to use several hands in order to get them in. But they'll work in a pinch. They work once you get them in, but very difficult to use. But having an assortment kind of covers you for different emergencies. All right, now I'm going to try to put one of these in, if I can. But you see what I'm saying about having a pre-defined what have you. This is going to substitute for my steel plate, I hope. So I'm going to kind of freehand this one down in there, and just rather than using the press. Okay, that's going. Oh no! Come on, let go. Ah. See, it was trying to stick to it. Here we go. That worked out, and we managed to salvage it. I actually put too much heat on it, and so it was trying to adhere to the soldering iron. Let's try another one of those. And that worked out pretty well. I'll be honest, I had not tried that technique of pushing them in with a, well, that one doesn't quite, that's tight. That one's back down there. Yeah, it's, well, can't see it. All right, turn it around where I can see what I'm doing. And this time I won't go quite so long as soon as it starts to move. Okay, there, I got it. All right, there it goes down in there. And there we go. And so that one's in there. It's the big thing you're trying to do is get these things in there square, so they're pointing straight up and not hooked off at an angle, because when you try to screw down to them, depending on the tolerance you've got in your parts, if they're crooked, you'll be in for a time of woe. This is the hardest one, these two, because this right here blocks straight access to it from the soldering iron, so you have to be real careful. And I'm pushing, there it goes, I'm pushing it at an angle, so there it goes down in there. And see if I can finish it. Get down in there, yeah, good boy. And that one's in there. I think it's tilting outward just a little bit. It may have already solidified enough to, no, I guess that's okay. All right. All right. Tweezers. Tweezers are hard to beat. You can, they hold things so much better than needle nose pliers. And so I'm having to kind of go at an angle. Okay, there we go. Engagement. It's going in. We will press it with this. Try to straighten it out. Doggone. Looks almost store-bought, doesn't it? Well, that's it. Now that is for the large cover plate, which goes on here like that. And on the original model, here's one completed. Anybody want to buy this one? Let me know. I'll sell it to you for $12.50. This one, I had everything open and these lugs coming out to connect to the MrBulletFeeder. And that works, but the springy thing comes way down. It has to pull down and then come back up from underneath. And the way this wire is connected in there, it's wired in and soldered in place. I didn't like that. So what I have done in this design here is I've added a place on top for a terminal strip, which will be screwed down there, and you can solder to it with these lugs. And that's where the spade things will be. And to do them, I will use these little goodies that just will screw down in there like so. And so you'll just plug it in, and no mess and fuss. And down here on the bottom, we will have this cover plate. If I can get it. Oops, it goes this way. This cover plate, which will be glued ultimately to this one. But it has a big opening here for a jack, and we will just use, you know, the regular as purchased plug from the power unit, and then just plug it in. That's all there is to it. So to make this thing work, you stick it on, tighten 2 screws, you plug this in, you plug those 2, and you're done. And I'm trying to make this thing where, you know, people have asked for them, and I'm not going into business here, but I'm just going to try to help some folks out for those that might be interested. So you know what to do. There are comment places where you can do that sort of thing. All right, let's see if we can get these in there. All right, wide angle view here. We're just free-handed. Actually, that works really well. Just having something to hold the soldering iron is really all you need. Let's move in close. All right, you push, it almost instantly begins to go in. You get about halfway, you flip it, you press it, and that's it. Okay, on this one, I'll let you see the pressing against the plate. And I go over here and I heat it. It's melting down in there. I take it and I press it like that. And there it is. I guess I could be a little bit squarer. Okay. Okay, this is the LED. That was the light side, and this is the okay, that was the light side, and here is the solder side. The big one, the big pad is ground. The little one is hot. And let's just put it in here. I usually do it that way. Not that it matters, but, well, and I usually don't have this much trouble. I have trouble with a lot of things, but usually just this thing just drops. There we go. All right, now. All right, I'm going to attempt to solder this into place. First thing I want to do is get some solder on my on the tip of my iron, and then I'm going to hold that down against it, and I believe we got that one. And all right, let's see if I can do the other side, the positive side, and yep, that got it. All right, very good. Let's see if I can straighten out these wires. These, of course, feed through to the other side. And come on now. Don't give me any grief here at the last second. And get you down there like that. And the idea at this point is that the back plate, the cover plate, is going to well, where's my little poker? Kind of hold everything down into place. At least that's the plan. I think I'm gonna put some of this. No, I'm not. I'm gonna put this on there. I think that will. I've got this tacky glue here, and I'm going to see if I can put it down in there, kind of like hot glue, only it's not. And well, that held. Let's see if it will stay. I'll give you a closer look. Now you can see how it's a clear gel like glue, and I think that will kind of secure it. Originally, I designed a little bump to go right there to press down against it, but it was I had problems printing it, and so I just went back to having it nice and flat. And if push comes to shove, I could always glue some kind of a rubbery thing there to press down against it, but I think it's going to hold. Well, the glue dried, and the little LED is nicely in place. You can see I've added some more things too, but there it is, and that's holding very nicely. And then of course when we put the cover plate on here, that'll complete the job. Meanwhile, I have wired up power to it, so watch what happens when we plug in. Watch what happens to the LED when we plug it in. Ta-da! There she is, and it's a bright little sucker. And on the inside, we now have the circuit board mounted, and it's just a few wires. It looks a little bit messy because I put some extra wire in there for purposes of being able to get to things if you want to take the lid off for some reason. But meanwhile, this relay right here, those two are connected with soldered wires that have been insulated to this barrier terminal. And then I have these two lugs, and that's where you plug the two wires from the MrBulletFeeder. That's really all you have to do is just plug it in here and plug those on, and you're good to go. Now, the question is, does it work? Well, let's take something and put down in here and block the light and see what happens. That's much smaller than a bullet, so I trust you can hear it. Oh, works just fine. Let's check it with a meter and see if we're getting what we want. All right, let's see if it works. I already know it does, but I'll let you find out here. I've got a screwdriver stuck down in there to block it. Take it out. We make connection. It says 2.9 ohms. Oops. All right, so it works. And I will have to confess something here. I got mixed up and forgot which connections to use on the relay. This is the common, This one is the normally closed. This is the normally open. And if you look down in there, I really shouldn't have made, let's see, wait a minute. I really shouldn't have made this mistake, because if you look down in there, it's written in Chinese just as plain as anything. It says normally open and normally closed. Or shop at Sam's chop suey shop for the, no, I don't know what it says. Obviously I don't. But anyway, now when there's nothing in there, these two are connected. And when there's something in there like that, then that circuit is broken. So that opens and closes our switch. One last thing, that bulge that you see right there under the heat shrink tubing is a resistor, and it's that one, as a matter of fact. At any rate, that's in series with the LED, and you need a resistor there for sure to prevent burning out the LED. It needs a resistor in there. The value of the resistor will determine how bright the LED goes, and this one actually, it's not super critical. I just grabbed one out of my drawer full of resistors, and this keeps it from being too bright. If it's too bright, you just really, it's so much light you can't get the thing to turn on and off. So this seemed to be a really good value. Something around 800 ohms is good. And you can see our little coil of wires here is nestled in there pretty well, and it's going to go together just like that. I just love these brass inserts, these heat set nuts, because it gives you a machine thread. You're not using those tapered screws with the big threads to go right into the plastic, because if you use that kind, if you will know probably that after taking it apart a few times, the plastic will wear out, and it's really easy to strip the plastic. But here you have a metal to metal contact, and it's just nice. And you can take it apart and put it back together just time after time. You need some of these, let me tell you. This is to work on small things like this. This is just what the doctor ordered. And I don't think I've actually showed you this one. There's actually one more screw up underneath here. I tell you what, these little screws can be a challenge to 74-year-old fingers. I'm here to tell you that. But yeah, that's it. And this is your power. And where'd that thing go? So here's from the wall wart, and plug it in. In fact, you can see it. You can see it glowing down in here. Look at that name on there. Isn't that something? Well, if you're proud enough of your work. Wait a minute. Here we go. Now we know it's you can see it's not extremely bright. It's bright though. It's pretty bright. Bright enough. Bright enough to do its job. All right, let's put it back together and then we'll have a wrap up. All right, let's see if we can make this thing come to life. Okay, it's full of bullets, so what I'm going to do is dump them all at one time. And we'll let it fill back up, and there you see them coming in. And when they get up to here, it'll stop. And I'm going to take a case and put it back here under the bullet feeder. And I'll come down. That drops that one, and the level will come down by one bullet. And there's that bullet. Now, as I said, a lot of times it will be the second one that lets it go. And you could hear it there. Turn on. And it may turn on this one, it may not. Nope. And then this one. There it goes. So it'll always keep it full. In fact, I think what's happening is doing every other time and running for 2 bullets. Maybe, who cares? It works. I mean, it's the height of the bullet is such that just, that's what's causing that little bit of glitch in there. But that's not a problem. It's working absolutely flawlessly.